Hello, my name is Jacob Parker, and today I'm going to be showing you how to solve this second order differential equation using Laplace transform. So we have this equation here, y double prime plus 3y is equal to e to the 4t with the initial conditions of y of 0 is equal to 1 and y prime of 0 is equal to 0. The first step is to take the Laplace transform of each component. And when we do that, we should get this expression here, s squared times big Y of s minus s plus 3 big Y of s is equal to 1 over s minus 4. The second step is to solve for y of s. So we move this little s over and factor out the big Y of s, and then we'll need to multiply the little s by 1 to get this all into one fraction, and then we'll divide by this s squared plus 3 to get this expression here. The next step is to change the y of s to match the table's entries. And in order to do this for this particular problem, we'll need to use partial fractions. And the first step of this is to write out the expression here. And then we'll have the expression is equal to a over s minus 4 plus bs plus c, and this bs plus c is there because of this s squared. The second step is to multiply by the denominator of this part of the fraction right here, and then we'll get this expression here. And then we'll need to solve for a, b, and c. There's a couple different ways to do this, but I like to pick values for s and then like to eliminate variables and then solve from there. So for the first value, I picked 4 because that made everything except a go to 0, allowing us to see that a is equal to 1/19. The second number, I chose s is equal to 0, and then this left a and c, and we already know a, so we can find c to be negative 4/19. And then s equals 1 for the last one, and we'll get a fraction with all of the variables, but since we know a and c, we can solve for b is equal to 18/19. So just putting it all together, this fraction right here is equal to this expression here. So then we'll need to plug it back in to the y of s expression and kind of reduce it to match the table entries. And everything is good except for this last one, because we'll need to multiply it by square root of 3 over 3. And this is just broken up into two parts, this part and this part, into two fractions. And the reason you multiply it by square root of 3 over 3 is to match the table entry. Then you'll get this expression here. And then you need to take the inverse Laplace transform to find the answer. So the first one uses entry number 12, where a is equal to 4. The second one uses table entry number 13, where k is equal to square root of 3. And then I just converted this expression to get the square root out of the bottom, and then this uses table number 14, where k is equal to square root of 3. And then when you plug everything in, you get y of s is equal to 1 over 19 e to the 4t plus 18 over 19 cosine of square root of 3t minus 4 square root of 3 over 57 times the sine of the square root of 3t.